What's up, everyone? This is LeetCode 54, Spiral Matrix. We've done this problem in Python. Now we're going to do it in C++. This problem isn't too difficult to visualize and conceptualize what you need to do, but the implementation is a bit tricky, right? So we're just given a matrix, and we have to return all the elements in a spiral order. Okay, pretty simple. So basically, this is our matrix, right? And we just need to return all these elements as we go along the spiral, right? So pretty simple on terms of what you need to do. The implementation is difficult though, right? And so I'm going to kind of just get right to it and kind of talk about our approach, right? Not even going to waste time. So the idea here in this problem, right? The trick really is that you're going to have like imaginary walls and right, and that's going to basically define the boundaries as you go along for basically doing the spiral, right? Because if you look and pay attention, right? What is one thing you notice about our spiral, right? It's that as we go along our spiral, what are we doing, right? We're going right, down, left, up, right, down, left, up, right, down, left, up, right? So you need to keep that in mind because that's basically our steps, right? And we're going to use these walls to our advantage as we do each of those steps continuously until we're done, right? So we're always going to start at the top left, right? Of our matrices, right? So we're going to go here and we're going to go right. Okay. Well, when we go right, what do we just handle when we go right here? When we handle these three elements? Well, are we handling a row or the column? Well, the row's staying the same, but the column is shifting, right? Okay. So, we just handled this entire row basically now. When I say the column shifting, I mean as we go along, right? When we do matrix of ij, right, the j is changing, but the I is staying the same. So we handle this entire row. So now this top wall can move down, right? And now we go, so we did, right, 1, 2, 3, right? And now we're going to go from top to bottom, but again, we moved our wall down. So we're not going to start here, which is a good thing, right? We don't want to include this 3 again. So we're actually going to start from this 6 and then handle this 9, right? So again, this time our row is changing, right? Because we're from the matrix ij, where the I is changing, right? So now we handle this, right? We added this 6, this 9. So what changed here? Well, this right wall can change because we handled all these elements. Right, now we do 8, 9, or sorry, not 8, 9, 8, 7. I'm going to do 8, 7. And so we handled all these now. So this wall can move up, right? Then we handle this 4 and this 5, right? Or sorry, not this 4 and this 5. When we move this wall up, we go up. So we handle this 4 first. So we handle the 4, and then we move this wall, and then we handle the 5, okay? Then we handle the 5. And when we handle the 5, this wall is actually below this one. So we're done. Okay? So yeah. Okay, so I'm gonna kind of write this kind of fast, just basic matrix stuff, like get our matrix. We're gonna say the int the columns is gonna be matrix of 0 dot size, right? These are our walls, right? So the top wall, we can just do it all on the same line, right? The bottom wall, right? Then the left wall and the right wall. Okay. And then we're gonna say, well, top is less than or equal to the bottom, and the left is less than or equal to the right. We're gonna move from left to the right, and so we're gonna go from int I left, right? Because we're going from left to right, and so I should go to the right, but it should be inclusive. Remember that, right? When we're going from left to right, we start at the left, we go to the right, well, and it should be inclusive. And so as we do that, we need to push to our answer. Let me create that. I forgot about that. This is just what we're returning, right? Because remember, as we go along the spiral, we need to add everything to basically a vector and return that. Okay, so we're going to say vector int answer. Okay, and this is what is going to get returned. So let's just do that down here. Okay, so we're going from left to right. Like example 1, we're going 1, 2, 3, right from the left to the right, inclusive on where we are ending. So we're going to do answer.pushback the matrix. And so when we handle what row and what column are we on? What is changing here when we're going from 1, 2, 3? Well, the row is staying the same, right? So that should be the top wall. And what is changing? The column, which should be the I, right? And so when we are done with that, remember what changes here? The top wall, right? So the top wall should go up 1. Okay. Then here we're gonna move, remember, from top to bottom. So we're gonna do, and let me just copy this. We're gonna have to change a few things, but just to save some code. So we're gonna go from top to bottom. Okay. And what is changing here? Okay, when we're going from this 6 to this 9, what is changing? And what is staying the same? Well, the column is staying the same. So the J would stay the same. And what column are we on? Well, we're on the right column, right? So the row is actually what is changing. And when we're done with that, what gets moved? Remember, the right wall gets moved, and that should go back 1. Okay? Likewise, copy and paste here. We're going to have to change a few things, right? We're going to go now from right to left, right? So we're going to go from right. And again, this should go to the left. Because we're going backwards, right? We're going from right to left. When we're going from 8 to 7, what is changing here, right? And what is staying the same? Well, the row is staying the same, and that should be the bottom row, right? So this should be bottom, and this should be I. And when we're done, the bottom row should go up, okay? Okay, then one last one, remember, from bottom to top. Okay, so we're gonna start at the bottom, right? We're only handling this 4, but in example 1, now that we're going bottom to top. So we're gonna start at bottom, and we're gonna go to top. But again, we're technically going backwards, right? Because we're not going top down, we're going bottom up. So I is greater than or equal to top, minus minus. And what is changing and what is staying the same? Well, the row, or not the row, sorry, the column is staying the same, and that would be the left wall, right? And the row is changing. Okay, and then when we're done with that, the left wall actually gets moved. Boom. That's pretty simple, and we're done, almost. But there is a certain edge case we need to handle, which is something with our walls. Okay. Because if you'll notice, once I run this, oh, little errors, my bad. I think I copy and pasted when I had a missing parentheses. So now all these have missing parentheses. But so what you'll notice here is, for example 2, we have an edge case where we go like this, except because the way our walls are structured, we're adding all these, except at the end, we're also adding an additional 6, okay? And I'm going to go over why that happens. Okay, this is example 2, everyone. So, so let's just kind of do this really quickly. So we're going to go from, I guess I'll write this down as we go, right? So we're going to handle 1, 2, 3, 4, right? We're going to handle 1, 2, 3, 4, and then we're going to move this down, right? Because we're done with it. We're done with this row. Then we're going to go 8, 12, and again, this is example 2. Then we're going to move this wall over. We handled 8, 12. Then we do 11, 10, 9. 11, 10, 9. Then we move this up. And then we handle this 5. We go bottom up. We handle this 5. So let's add that. Move this over. Then we go left to right. And we're going to handle this 6 and the 7. Okay. So when we handle 6 and 7, we move the bottom wall. Or the top wall, sorry. Now, the issue here is that when we move the top wall down, we're still in this, we already enter this while loop, right? Right, we already entered this while loop. So even though this is no longer true, we already entered it, right? Because this becomes untrue down here. right? Once we move this. So we still have to keep going. So now we need to handle top to bottom, right? Well, top is we can't go from top to bottom because top is not above bottom. So it's basically, you wouldn't handle anything here, right? This for loop wouldn't even execute, but the right wall would still move, right? So the right wall gets moved now here. Okay, now we're gonna go from right to left. And remember, it's inclusive. So technically we still handled this 6. So we are adding this 6 again, right? Right here. We're adding this 6 again. So we need to handle these edge cases, because once we handle these, we could have cases where because you know how we're moving the top wall and the right wall, we could have cases where the top is no longer, right? The top is no longer above the bottom wall, and the left wall could no longer be to the left of the right wall. And so we need to handle edge cases for these, right? So that we don't run into this issue, right? Because basically we're handling right to left here, but we shouldn't, because these walls aren't even in the same spot, right? This wall, because remember, these walls are just boundaries, right? It's saying, hey, look at this. But if this wall's down here, why are we going from right to left? Likewise, right? If this is a boundary, right? But if the wall is here, what are we checking exactly? We shouldn't be checking anything, right? And so that's kind of what we need to do, is we need to handle certain edge case checkings here, right? So what we're going to do is we're just going to add a simple if statement, okay? So we're going to say if the top wall is less than or equal to the bottom wall still, then let's handle this, okay? So let's go here, boom, copy paste. Okay, that didn't work well. We'll just do it this way. Likewise, let's just, whoops, let's indent that. We're going to say if the left wall is less than or equal to the right wall, then we can handle it. Okay, that's just basically our edge case checking, right? So now we don't have this issue anymore. I hope that visualization helped, but it's basically the way our walls are structured, where they basically, so they have to be valid for us to enter a while loop, right? But basically our walls could become invalid somewhere in here, and so we want to make sure we account for that later on, right? Because technically our walls could be valid, so we enter the while loop, but they could become invalid at some point, and that's basically where we would run into issues, right? So here's our code. I know it's kind of a lot. Kind of hard. I keep it all on. I keep my brackets on their own line, so maybe a little bit hard to read, but right, you can just look at it, right? Pause the video if you need to. But it's pretty simple. I mean, really, we're just going forward directionally, right? We're going right, down, left, up, right, down, left, up. That's what this while loop is for. And we need to basically use the walls to keep doing that spiral. And when the walls become invalid, we're done, basically. And they could become invalid within the while loop, which is why we need these if statements. Okay? So I hope that helped. It's really not the easiest problem in my opinion. I think it's a little bit tricky, but I hope I helped a little bit. And yeah, I don't remember if I submitted, but I will submit again if I didn't. And it works. Okay. Peace out, everyone.